angles. Still related to how a transversal, vocabulary word, crosses two parallel lines. And then what we get from the relationships of, different pairs of angles tells us whether they are supplementary or our favorite math word, congruent. It's favorite. You better make it your favorite. Just kidding, you do you. Since we're on page 307, I wanted to also draw attention to something that needs to be visible. You should be on these workspaces in Mathia. Classifying angles formed by transversals, calculating angle measures formed by transversals, calculating angles formed by multiple transversals, and proving parallel line theorems. If you're not there yet, maybe you need to go focus on your Mathia work to get caught up to the content of this lesson. I have a highlighter. We're going to acknowledge what mathematicians do. We are going to reason abstractly and quantitatively in this lesson, in this video, in this activity. We're going to construct viable arguments and critique the reasoning of others. And really in this one, on this page 307 work, all we're really doing is just annotating, reading through someone else's response just to figure out what did they say that we could also use as our own example. And because this is an example where someone else's thought process is being visible, I do recommend that you put a little dog ear in this page so that when you need an example of how someone else is thinking, you can come back to this page and see it. Maybe it'll stand out in the corner of your book a little bit better. A helpful technique, here we go. A helpful technique that you can use to write proofs is to start by writing a proof plan. When you write a proof plan, you use a combination of your own words and mathematical language to describe how you connect the given statements to the proved statements, and then use postulates and theorems to do this. When you write a proof plan, you can test it and fill in missing steps before you write the actual proof. All of this is to say, this is the English language arts equivalent of pre-writing. When you start writing an essay, you gotta do your pre-writing. In mathematics, when you are writing a proof, you gotta do your pre-writing. So sometimes that's an outline. Sometimes that's just putting this stream of consciousness about what sort of vocabulary you know, what sort of intuition you already have, hints that you might have picked up along the way. You get access to all of the note cards that you've created that might have a connection to something that you've used before, and you bring all of that to bear in your pre-write. And afterwards, after you've done a good job, maybe you have a friend or your teacher, or you think about it for a while and come back to your pre-write, any of the gaps that are there in your proof will start to fill in. Consider, for example, the conjecture you made earlier regarding alternate interior angles. That's a vocab word I don't want to lose. I hope you made your note card on it too. Alternate interior angles. You conjectured that if a transversal intersects two parallel lines, so transversal. If a transversal intersects two parallel lines, then the alternate interior angles are congruent. So angle 3 and angle 6 would be congruent. And what I'm doing right now, even as I add notes to the diagram, is what you're doing when you do pre-write. Take a diagram, think about one sort of math statement that you made, a theorem, conjecture type of thing, and then start adding your own details to the diagram itself. Let's talk about one specifically. Given that W and X are parallel and Z is a transversal, all of that given, it's two statements really, but its reason is that we are given that as information. And we need to build on that from there. Let's figure out what it is that we have to prove. We have to prove that alternate interior angles are congruent. Alternate interior angles, like angle 3 is congruent maybe to angle 6, or angle 5 is congruent to angle 4, maybe. We don't know. We do, but we don't formally know. Let's analyze Abelina's and Madison's proof plans. In order to do this step, I encourage you to have something to write with, have some highlighters. We're going to see what their statements and reasons are, and we're going to also say that's the first step of what they did. Let's go. Abelina, she says that she will show that alternate interior angles 4 and 5 are congruent. Okay, so I know what she's talking about. 4 and 5, and then as a statement, like that is the thing that needs to be proved. It matches the prove statement up above, so I'm going to highlight that orange. Right? That's the, I have to know what she's going to do. It's like a thesis. Oh my God, notes on the side from English class. This is like a thesis. It's given that a transversal cuts the two parallel lines. Okay, highlighting statements yellow and reasons pink. It's given that a transversal cuts the two parallel lines. Why? Because given. So I know that angles 4 and 6 are supplementary. So that's another statement. Angles 4 and 6 are supplementary. And because they are same side interior angles. So there's my because, there's my reason. Again, statements yellow, reasons pink. That's my process. I'll put it over here. Statements, reasons. Statements are going to be highlighted yellow, and reasons are going to be highlighted pink. Now, she just made a statement. She said angle 4 and angle 6 are supplementary. So when we go look at the diagram, because they're same side interior, then we're looking to see if angle 4 and angle 6 are on the same side of the transversal and are interior, like between the two parallel lines, and you know what they are. So she's right. She's done a correct analysis of how angle 4 and angle 6 are related. Okay? The next up is angle 5 and angle 6 are supplementary. So that's a statement. Angle 5 and angle 6 are supplementary. And the reason is because they are a linear pair. Again, statements in yellow, reasons in pink. So angle the measure of angle 4 plus the measure of angle 6 equals 180. That's a statement. And if we needed to comment on why it is, I'm going to write, she knows this because she said supplementary. Right here. Okay, but the measure of angle 5 plus the measure of angle 6 is also equal to 180. That's another statement. And she's allowed to make that statement because she said supplementary. So we have supplementary being used twice. And if we see a vocab word like supplementary being used twice, then we're probably going to have to use the 180 thing. I mean, think about it. Supplementary angles is one of our vocab words, and the fact that we have equals 180 lets us get into the realm of numbers. That means that angles 4 and 5 have the same measure. Now, this one might not be immediately obvious. I hope that you have your note cards, and if I can flip through my note cards quickly, she used a given, right? And here, so you can see what I've highlighted. Angle addition, linear pair, vertical angle, definition of congruent, reflexive property, central angles, corresponding angles theorem, right angles, transitive property, addition property of equality, right angle theorem, subtraction, substitution, definition of supplementary angles. That was used. Segment addition, alternate interior. There it is. The congruent supplement theorem. The congruent supplement theorem says if two angles are supplementary to two other angles, like 2 and 4 are congruent, 1 and 3 add up with those angles to make 180, then angle 1 and angle 3 are congruent. So I'm going to add that little note down here. I use my big brain and what we did in a previous lesson, activity, video, etc. to find the note card where we talked about congruent supplements, and I'm building connections from previous content. That's what you have to do to be successful. So I'm going to write by congruent supplements theorem. So even though she did a great job, Abelina did a great job putting forward how she thought about the math and what she needed to have in order, I can still add to it. I'm annotating, I'm adding highlights, I'm adding words along the side, and I'm filling in a gap that I think she had. Okay, this video is going to continue a little bit longer. You can obviously tell by the time code on the bottom of the video that we have to talk about Madison and her statement. By the way, I totally agree with what Abelina said. I am a thumbs up on her statement. Her reasoning is awesome. Madison has a different way of thinking. Not wrong, not like one is better than the other. But let's get into it. Let's see what she says along the way. And of course, highlighting. I need to prove that angles 3 and 6 are congruent, which means they have the same measure. So that is the prove section. You need to identify, so I'm using a different color, you need to identify the prove part of the statement. And I even love the fact that she says that means. Several times you guys have asked me what congruent means. It means they have the same measure. They're the same size. They're equal. Remember that. The given states that the lines are parallel and cut by a transversal. So we're going to highlight lines are parallel and cut by a transversal. She said it a little differently than the way Abelina did, but she still acknowledged the given, and you need to do that. That should be one of your note cards. Have given be something, and it's going to be in every single proof we do. So angle 2 and 6 are congruent. Statement. But the reason for that statement is because, so that's a key looking for word, because they are corresponding. And you need a reminder, corresponding angles open the same way. So angle 2, which is up here, and angle 6, which is right here, they both open up and to the right. And one is in between the lines and the other is outside of the parallel lines. And if you don't have a corresponding angles card yet, you really do need to make one, right? So if I can flip through and find one quickly. Corresponding angles, there it is. The definition of corresponding angles says that these angles that open in the same way must be equal, they're matching each other, and therefore their measurements are equal. Make a corresponding angles card. She did. Okay, back to highlighting. But angles 2 and 3 are congruent because they are vertical angles. So remember, we're still talking about things, oops, get out of here, you. We're still talking about things like vertical angles because of their importance. And where is my, there it is. It's kind of off the camera window there. There we go, camera window. There's vertical angles, like it's on the wall. It's something that you need to be able to recognize too. Vertical angles, opposite from each other, they're equal. So if you see parallel lines cut by a transversal, well, one time the lines that are crossing are equal. She's focusing on 2 and 3. 2 and 3. They're equal. They're vertical angles. So Madison is still using vocabulary that we've been talking about. If 3 and 6 are both congruent to angle 2, then they must be congruent to each other. So they must be congruent to each other. So she's missing a couple of like reasons for that statement and that statement. Remember, every statement in yellow gets a pink reason. So if 3 and 6 are both congruent to angle 2. Okay, so on the side, I'm going to add some notes. Angle 2 is congruent to angle 6. Angle 2 is congruent to angle 3. I know I've seen this one before. I mean, of course, right? I'm playing the fool here, but I know that you, with our notes and our note cards, have seen this one before. It is the transitive property, right? 2 and 6 are congruent. 2 and 3 are congruent. So that means that they are congruent to each other. Angle 3 is congruent to angle 6 by the transitive property. And so that's the goal of what we do with the proof, is that we figure out maybe the gaps that still need to exist. Here's the back of the transitive property card. We're figuring out the gaps that need to exist, like to fill in what you said in your proof. There's maybe like a little piece that's missing. Use my expertise, use the expertise of another teacher, a tutor, some online resources, do your Mathia, do the tasks, and then see how you can also improve in your ability to find the missing link. Thank you so much for watching this video on page 307 about alternate interior angles. Just as a reminder, Madison showed us angle 3 and angle 6 are congruent. They are alternate interior angles, so therefore we've got a response to the proof. Let's see where this takes us in the next video. See you on page 308. Thank you so much for being here today, and I'll see you later.